Okay, we're away for part 2 here of our solutions to the practice sack. So we've just finished question 8, so let's kick on to question 9. Is a continuation of the same scenario. How long does it take the aircraft to reach 100 kilometres an hour? So let's put our knowns in. We know its initial velocity was 0, and we know the distance it's travelled was 83 metres. Okay. All of these have been given to us, and we know the acceleration is 36 metres per second. Okay. Alright, so we want to know V is 100 kilometres an hour. We know we can't put kilometres an hour into our formula, so we need to convert that. So to go from kilometres an hour to metres per second, we're dividing by 3.6. Okay, so that gets us to 27.78 metres per second. So, I don't know, it doesn't look like we're going to have to use the whole runway. So, we know we're starting from rest, we're accelerating at this rate. How long does it take to get to here? So that's a time question, how long? So we've got our U, our A, our V, and we want to know our T. U, A, V, T. U, A, V, T. V equals U plus AT. That's the one we want to use. V equals U plus AT. So V is 27.78. U is 0 plus acceleration is 36 times by time, which is our unknown. Okay? So again, formula substitutions. Alright. 27.78 equals 0 plus, well that's 0 disappears, so we just end up with 36 times t is 36t. Divide both sides by 36. So we have 27.78, still in my calculator here, divided by 36. 0.77, that's time, so that's seconds. 0.77 seconds, which is a very short amount of time to make it to 100 kilometres an hour, but it's accelerating at 36 metres per second every second. So, and if you want to check it, 36 times by 3.6 to get into kilometres an hour is over 100 k's an hour, so it has to be less than a second. So that makes sense. Right, over the page. Question 10. 2 soldiers in Afghanistan accidentally fire a mortar round straight up into the air at 55 metres per second, ignoring air resistance. Find. Okay, so let's draw a picture of our scenario. Mortar round goes up, mortar round comes down. The initial velocity of that mortar round at this point here is 55 metres per second. And at the very top, we know its velocity is going to be 0. So this is what we can do. We can analyse this half of the motion. 2 soldiers, okay. Alright, and if it's going straight up in the air, we know acceleration will be due to gravity. And if we're going to call this plus, we're going to give this a positive 55, because it's acting upwards and gravity is acting downwards, so we're going to have to give that a negative. Let's use the round number of 10 metres per second squared. So, known, there's our 3 knowns. Maximum height. Maximum height's going to be at this point here. So, all we need to know is the distance. So, we've got V equals 0, U equals 55 metres per second. Acceleration is minus 10 metres per second, and distance is what we want to know. VUAX, look at that. V squared equals U squared plus 2AX. V squared equals U squared plus 2AX. Alright, let's substitute our values in. Okay, 0 squared is 0. 55 squared. I don't have a squared button on this calculator, so I'll just do 55 times by 55. So that's 3025 plus 2 times by 10 minus 10 equals, oh gosh, who would have guessed that, minus 20. So minus 20x. So if we subtract 3025 from both sides, we have minus 3025 on this side equals minus 20x. Divide both sides by minus 20. And we get x by itself. So we have 3025 minus divided by 20 minus equals 151.25 meters. Okay. How long do they have to clear the area before the mortar round returns to the ground? So really what this question is asking is, how long is it going to take to go from being down here, up, and then back down? So we can stick with our plan of just analysing half of the motion, but we just need to know that when we calculate the time taken to get from here to here, we're going to need to double it. Okay, so the time it takes to go up is going to be identical to the time it takes to come back down. Okay, so U equals 55 meters per second, V equals 0 meters per second, acceleration equals minus 10 meters per second squared. Now it's not distance, it's time. UVAT. It's going to be V equals U plus AT. V equals U plus AT. V is 0. U is 55 plus A is minus 10 times by T, which is our unknown. Okay, if we subtract 55 from both sides, we end up with minus 55 on this side equals minus 10t. Divide both sides by minus 10. T equals 5.5 seconds. Right. So, like I said, the information we're putting into this formula is just from here to here. So, the formula's told us that's how long it takes to get from there to there. We know that the time it takes to go up is the same as it's going to take to come back down. So we need to multiply that by 2, which is going to be 11.0 seconds. Alright, let's keep going. How long's this been? Probably not going to have enough time to actually do this, but what I'll do as an introduction to get you rolling is get you to consider that you're going to have to do 2 calculations here. So if you like, I could represent this information as a velocity time graph just to help illustrate my point. So Travis is driving along the road at 70 kilometres an hour. When a cat runs onto the road up ahead, he applies the brakes 0.4 of a second later. Whilst the brakes are applied, he decelerates constantly at 8.4 metres per second squared until his car comes to rest. So what he's doing is he's doing constant velocity for 0.4 of a second, and then he's decelerating constantly until the car comes to rest. Okay, so what you're going to have to do is find out the distance he's travelled for his reaction time, and also the distance he's travelled for his braking time. All right. So these are the 2 separate calculations you're going to have to make. All right. In the next instalment, we will solve this one, but that's it for now.